In this example, we're going to use a combination of rules of exponents. One of the ones that we're going to use is the power rule, or one of the power rules, which is that if you had a to the m raised to the n, if you have an exponential raised to another power, you multiply the exponent, so that'd be a to the m times n. And also if we had, let's say, ab raised to the m, if you have only the product of these two values raised to the single power, then you raise each factor to that power, so you'd have a to the m, b to the m. And we're also going to use that if you had the product of two exponentials with the same base, let's say a to the m times a to the n, that what you do in that case is you add the exponents. That'd be a to the m plus n. So for this first example, we have the quantity a to the fourth, b to the seventh squared, and then a cubed, b to the seventh, that cubed, and then ab cubed, that squared. So we're going to first use the power rule that if we had a to the fourth, b to the seventh squared, we're going to raise each of those to the second, so that'd be a to the fourth squared, b to the seventh squared. And then we do the same thing for the next two as well. So this would be a cubed cubed, b to the seventh cubed, a squared, and then b cubed squared. And then using the power rule here, that if we raise an exponential to another power, you multiply the exponent. So a to the fourth squared, that'll be a to the eighth. Then the b to the seventh squared, that'll be b to the 14th. A cubed cubed, that'll be a to the ninth. B to the seventh cubed, that'll be b to the 21st. A squared, well, that'll just be a squared. And then b to the third squared, that'll be b to the sixth. Next, we're multiplying all six of these factors together. So remember that multiplication is a commutative operation. So we could always think of this as a to the eighth, a to the ninth, a squared. So we could group together the a factors, and then we'd have b to the 14th, b to the 21st, b to the 6th. And now we're multiplying these exponentials with the same base, so you would add their exponents. So a to the 8th times a to the 9th times a squared, that would be a to the 8 plus 9 plus 2. And for the b, it would be b to the 14 plus 21 plus 6. So adding those, so you'd have a to the 19th, b, let's see, that'd be to the 41st. Now for this next example, it's very similar. It's just we have this numerical coefficient in front. So we would do the same thing. So you'd have that 2 cubed, x squared cubed, y to the 7th cubed, and then we'd have the 3 squared, x to the 5th squared, and y to the 3rd squared. And then using that power rule, well, first 2 cubed, that's 8. Then x squared cubed, that'll be x to the 2 times 3, so that'll be x to the 6. B to the 7th cubed, that'll be y to the 7 times 3, so y to the 21st. And then 3 squared, that'll be 9. X to the 5th squared, that'll be x to the 5 times 2, which would be x to the 10th. Y cubed squared, that'll be y to the 3 times 2, so y to the 6. So rearranging these, we'd have the 8 times 9, so that'd be 72. Then we'd have the x to the 6 times x to the 10th, y to the 21st times y to the 6th. So this would be 72. Then x to the 6 times x to the 10th, that'll be x to the 6 plus 10, so that'll be x to the 16th. And then y to the 21st times y to the 6th, that'd be y to the 21 plus 6, so that'd be y to the 27. So those are now both simplified.